Image processing is all around us in our everyday life. Some we notice, some we don't. Everywhere from video games consoles to Google Glasses and even QR and barcodes, image processing is present. Image processing is essentially to take an image, then extract some information from it to calculate a categorizable outcome. For instance, there is a cat in this image. Of course, we may be able to see ourselves that there is a cat in the image. In doing so, 24/7, 365 days a year, that takes a little effort. That's why we use computers. Not necessarily always why we use computers, but it always comes down to, is it useful?
So, Peter, where are we going right now?
We are heading towards Aalborg Selvforsvar and Jiu-Jitsu Club, where we are having an appointment with a guy called Henrik, who knows a great deal about Iaido, for this pure sake that we want to see if we can find a problem to apply image processing to concerning Iaido.
So, can you explain to me what exactly Iaido is?
No, I can't. That's why we're here, actually. Hopefully we'll get to train some Iaido. The thing about Iaido is that we work with sword finishes, and thus we work with an imaginary enemy.
So this is where we might be able to use some image processing to this thing. Where are we hitting? Did we actually kill the target, or did it live? Just training Iaido doesn't show what is important and characterizes it, so we asked our expert.
Jamen, den centrale del i Iaido er jo skæret, så det er meget mere, at skæret er i orden. Og så er det jo noget med balance, og ellers bare have et flow igennem kataen. Men det vil hele tiden være noget, som vil kigge mere og mere ind på. De første 2 gradueringer, det handler mest om at følge træning, og ud fra det vil man være i stand til at bestå. Kravene er ikke så høje til de første par gradueringer.
The general framework for image processing consists of image acquisition, which is everything with the camera, pre-processing, like converting images to grayscale, segmentation, which is to convert to a binary image, then representation, which is to represent each of these objects, and classification, which can then tell us what these objects are. Previous work shows that it's a good idea to use color segmentation, but we've also looked into something like skin detection based on skin color, and even the Kinect, which uses infrared light to map to a 3D skeleton. Finally, there's background subtraction, which subtracts the background for segmentation. Based on our Iaido knowledge, we know there's a lot of tradition, and the clothes cover a lot, and we change balance before cuts. So we can start by excluding the color segmentation and the skin detection, as the body's covered all up in black clothes, so there's no skin or colors. The Kinect would be good too, but it's simply too expensive. This leaves us the background segmentation. From then on, we derive the problem statement: how can we create a computer vision system capable of detecting complex human movement? We must consider false and negatives, movement in template matching, and detection accuracy in pixel values. When the user starts, the loaded video will then undergo segmentation, post-processing, classification, matching from the database, camera matching, best matching templates for each frame. The saved match sequence will then again be checked multiple times until it gives an end feed.
Oscar, what are we doing up here?
Well, we're about to shoot some new footage because the previous footage we shot was basically shit and we can't use it because, well, we kind of put black bags in the background the last time we took this, which meant we couldn't extract the silhouette.
So naturally, we had to record some new ones.
It works!
After extracting the necessary silhouettes, we conducted internal testing as it was too late to test with test participants from external sources. It was a success to this extent, and it looks promising.